Hello, my name is Alison Jean from the Empathic Computing Lab at the University of South Australia. I'm here to present our work titled The Impact of Sharing Gaze Behaviors in Collaborative Mixed Reality. In this paper, we report on the impact of sharing visualizations of gaze behaviors in collaborative mixed reality (MR) application. We first present an MR system that converts gaze behaviors to virtual visualization cues shared between remote collaborators. We then report on two studies with participants in local and remote roles, completing visual searching and puzzle-solving tasks in physical workspace. The main novel contribution of our research are, first, the first study to evaluate the design of shared gaze behaviors through a collaborative MR interface. The first study to examine the effect between gaze styles, bidirectional versus unidirectional, and gaze behaviors, on or off, in 360 mixed reality remote collaboration. A user study to compare shared gaze visualizations, as known as SGVs, against no gaze in MR physical task space. Previous research showed the benefit of using SGVs to support remote collaboration in traditional modalities such as desktop screens and 2D displays. Studies conducted using MR system with 360 panoramic video sharing have created opportunity to further explore the use of SGVs in situated physical environments. Although MR SGVs have been used in several studies, the visual feedback has been mostly unidirectional with no behavior states. Therefore, investigating the benefit of integrating gaze behavior states and the effect of coupling gaze factors in different levels using MR in situ physical remote collaboration will encourage the utilization of gaze cues in such environments. Our system is a live 360 panoramic video-based MR remote collaboration system that turns various gaze behaviors into virtual visualizations and shares them bidirectionally. The local user, equipped with the AR headset in the physical task space, shares and receives verbal gaze cues from a remote collaborator in VR, immersed in a live 360 panoramic video of the physical task space. Prior studies commonly use a unidirectional indicator to visualize the partner's gaze focus point. In this research, we also include a bidirectional gaze style to show that the participants' own gaze and their partner's gaze indicate simultaneously. For gaze behaviors, there are two levels of designs, behaviors on or off, to compare the differences between having or not having behavior cues during remote collaboration. Interface variants are developed to represent a change of gaze behaviors known as GB states from the default browsing to focus and joint. We have chosen the two most commonly used visual attributes, color and shape, to direct user attention during the switch of GB states. The goal of the first user study was to evaluate a design of three bidirectional MR gaze interfaces representative of the change of color, shape, and both color and shape. We employed a within-subject design among 6 groups of 12 people. A collaborative puzzle-solving task was used between remote and local roles. 7 Likert scale rating and ranking were used to measure subjectively. Results suggest the distinctive visual feedback of the SGVs showing gaze behavior states, hence collaborators shared attention in mutual communication in free-form task space. We proceed using condition both as a main design for next study. The second study focuses on 2 main aspects. First, to understand the effectiveness of having SGVs compared to no gaze visualization. Second, to investigate the interaction effects between gaze styles, GS, and gaze behaviors, GB, in remote collaboration. The study used a within-subject 2x2 factorial design with 2 independent variables, GS and GB, having uni versus bidirectional GS combined with the GB on or off. 4 SGVs are defined as bidirectional with behaviors, bidirectional without behaviors, unidirectional with behaviors, unidirectional without behaviors. We then also added a 5th no gaze condition as the baseline to compare against. 12 groups of 24 people were asked to perform 2 collaborative tasks. Finding duplications, which is a symmetrical task between local and remote roles, and guide to locate is an asymmetrical task. We created gaze behavior metrics as objective measure, rating, ranking, system usability scale, as well as open-ended question as subjective measures. Here's a quick demo of our study. So this is the first one, the second one, the third condition, and fourth condition. Results indicate that the SGVs showing behavior factors in a bidirectional format enable frequent joint gaze interactions, thus improving gaze alignment visually and quick reaction to the shared interest in a spatially complex text environment. Additionally, compared to the no-gaze condition, SGVs align collaborators' current focus in constantly, requiring less complex vocalization to orient partners to the target among many in-situ objects, therefore lowering the cognitive load for achieving mutual understandings. User felt that the bidirectional behavior visualization showing both collaborators' gaze states was the preferred condition since it enables easy identification of shared interests and task progresses. To conclude, in this research, we presented a live 360 panoramic video-based MR system, which shares 4 types of gaze behavior visualizations, consisting of 2 levels of gaze styles and 2 levels of behaviors via 3 types of interface between a local user and a remote collaborator. The result of the first study indicates that more effectively in sharing attention and enhancing mutual communication. The results from the second study suggest that encouraging frequent joint gaze interaction and SGVs have improved active mutual reaction to the shared interest. In the meantime, task coordination has become less verbally complex, while finding mutual targets and orienting physical manipulations, leading to lower cognitive load in a spatially complex remote workspace, ultimately resulting in enhanced mutual understanding and effective pair communication. Moreover, showing bidirectional gaze with behavior visualization was ranked as most preferred for providing balanced visual feedback of the pair's current focuses, making it easier to identify and align gaze states and behaviors.